Hi. So, in the last 2 to 3 weeks, we looked at the various processes of evolution, selection, mutation, migration, etc. And then we said that now we are going to look at the outcomes of those processes. And the first outcome that we are going to look at is aging, also known as senescence in the technical literature. Now, what exactly does one mean by aging? Now, in common usage, aging essentially refers to passage of time. So, the aging of wine or beer or cheese and so on. However, when it comes to biology, when it comes to living systems in particular, the term aging has a slightly different meaning. Now, what is that? Now, think about it. When all multicellular organisms, when they are born, we are born as a single cell, a zygote, right? And then that zygote divides and you have the formation of some embryo at some point, it becomes a fetus in the context of humans, and then at some point we come out of the body of our mother, and at that point we are roughly about this size, and then we as time progresses we become, say, something like this at some point in our life, and we become something like this, and then as time progresses other changes happen in our body, and somewhere towards the end of our life we end up like this. Now, is the entire thing called aging? Okay, and the answer for biological organisms is no. So, the first part that I talked about, when you go from a single cell all the way up to a baby that is born, that is typically called development. Then from the point when you are born, you are about this big, all the way up to this point when you come up to here, or maybe when you come up to here, that is also not called aging, that is typically called growing up. However, we know that at some point in our life things kind of start going bad. Okay. So, for example, at some point in our life we start losing hair like this, and or at some point in our life other physiological functions start going down, and typically it is this going down of the physiological function from the peak that it has attained, it is that going down what is called as aging or senescence. Now, I am going to define it properly in a few minutes, but right now we will just talk about this going down, the deterioration, so to speak. Now, what exactly happens during this deterioration? So, if you look at what is happening inside our body, okay, I am taking a slightly human perspective right now, but as I am going to show you, most of this is actually true across almost all known organisms. So, inside the human body, it has been shown that there are 12 major what are known as hallmarks of aging. Hallmarks means distinguishing features, specific features. Okay. So, this is a very famous paper, it came out in 2023. The predecessor of this paper actually came out in 2013, where they had ended up talking about 9 hallmarks of aging, and then after 10 more years they revised that statement and added 3 more, and that is how today we have 12 hallmarks of aging. Now, what are these hallmarks? So, I will just show you a list. So, these are things like the genome getting all kinds of mutations and therefore becoming unstable. There is a problem with what is known as the gut microbiota. The communities become the structure of the communities become altered, what is known as gut dysbiosis. You have the stem cells in the body becoming exhausted, you have inflammation in all parts of the body, chronic inflammation, and so on and so forth. Now, the first major point that you need to note over here is that these hallmarks, they are not really independent of each other. Many of these feed into each other. So, for example, the genomic instability that I have talked about here, some of it at least happens because of the second point, which is telomere attrition. We are going to talk about these things, not in this discussion, but in the next one, but some of these stuffs will get back. Now, if this were not an evolutionary biology course, I would have gone into the details of each one of these hallmarks, but because our aim is slightly different, we do not really have either the time or the bandwidth. Therefore, I will guide you towards this particular video by Science in Motion. It is slightly long, 13.54 minutes, but it is actually an excellently done stuff. Okay. Now, remember I told you that in 2013 they gave 9 hallmarks, and in 2023 they added 3 more, right. So, 9 became 12. So, this video predates 2023. That is why when you start, you will see that they are talking about 9 hallmarks. However, I also told you that these hallmarks are not independent of each other. So, the way 9 became 12 was because in 2023 they said that look, 3 of the things that we had spoken about earlier, but we thought that they were not of sufficient importance, hence we had not put them in the category of the major hallmarks. Now, we are putting them in the context of the major hallmarks. Okay, that is how 9 became 12. These were not new discoveries, they were simply a shift in the emphasis, and that is why although this pre-2023 video talks about 9, in reality it also covers those 3 other things like gut dysbiosis, chronic inflammation and so on. So, if you look at it, you are going to get all the information, and people who are slightly more advanced, who have taken let us say 1 or 2 courses in cell biology and biochemistry, I will strongly recommend them to look at the original paper itself. Very nicely written, slightly dense, too much of information, but if you know your cell biology, you will be enormously benefited by reading the original paper. However, as far as this particular course is concerned, neither of these are mandatory readings, which basically means we are not going to put questions from any of them in your exams. Okay. So, this is what happens inside the body. From our perspective, we are slightly more interested in looking at what happens outside. Okay, what exactly can we see? And here you see a picture of a 95-year-old lady, and on her lap you see a young boy. And if you try to compare the lady with the young boy, you can immediately see that there are certain things which are different. I mean, these are stuffs that all of us have seen, looking at our parents or grandparents, that as time progresses, for example, their hearing gets affected, right. They, particularly in terms of what frequencies that they can hear, their ability to hear high frequency sounds goes down drastically. Similarly, you have all kinds of wrinkles developing on the skin, which you can see over here very clearly. The body mass declines, both fat and muscle mass, they go down, and because of that, one of the major things that happens with old people is that their muscle strength goes down. They are not able to walk too much or as much as they could walk during their younger period. They cannot lift things and so on. Of course, one of the most well known thing that happens is that their vision declines, in terms of how far they can see and how accurately they can see. Similarly, this is the most well known feature. For most individuals, the hair turns grey, as you can clearly see over here in this picture too, and somewhere cognitive impairment sets in. They can't remember new things, many of the old things they tend to forget, their ability to understand new and slightly complicated thing often goes down and so on. So, these are very major changes, and the most important thing that happens is their probability of death goes up. Okay. An older person has a higher probability of dying typically than a younger person, that is like a given. Now, one thing I need you to understand is that there is a lot of individual to individual variation in all these declines. So, there are many 60-year-old people who, let us say, have more muscle strength than certain other 30-year-old or for 40-year-old people. Okay. So, that variation is always there, that is always there for any biological feature, right. But what I am telling you over here is generally true, on an average this is correct. Now, with this understanding of what are some of the outward manifestations of aging, we are now in a position to define aging, and we are going to define it from the perspective of two slightly different subjects. One is physiology or gerontology, and for a physiologist aging is a progressive deterioration of physiological function, some of which we listed, accompanied by an increase in vulnerability and mortality with age, which basically means that at some point your physiological functions will start going down and your probability of death will go up. If you look at an evolutionary biologist, they are going to say pretty much the same thing, except that they will put their emphasis somewhere else. They will say that aging is characterized by increasing mortality, mortality means chances of death, and decreasing reproductive success with advancing adult age. So, after a point your chances of death goes up, your reproductive capacity goes down, and that is what aging is. So, if you look at the two definitions, there is not any conflict between the definitions. Both are talking about increased mortality, increased chances of death with age. It is just a slight shift in the focus. The physiologist is focusing primarily on the physiological functions going down. The evolutionary biologist is focusing on the reduction in reproductive success and the reduction in or increase in mortality probability, right. Now, why these two people are doing things this slightly different way, this will become clear not in this discussion, but in the next one and the one after that, when we look at the various theories of aging. Now, till this point all the examples that I gave you, they were primarily in the context of humans, but as we all know, aging is almost an universal phenomena. There are very few animals or plants which are thought not to age, but even in those cases now people have started understanding that probably they are not immortal as the press says. It is just that for many of them things happen at a much slower pace than the time scale in which we have studied. However, without getting into those exceptions, if we just look at non-human animals around us, we can see them age all the time. I mean, anybody who has had a pet dog or a pet cat, you might have seen them age right in front of your own eyes. So, for example, here I am showing you a pet dog, a Neapolitan Mastiff, and can you see the white hairs on its muzzle over here, right? And this should remind you of for example white hairs on my face or white hairs on my moustache, and they are exactly analogous to that, right. So, the point I am trying to make is that aging is an universal thing and by no means is it a human only stuff. And the other distinction that aging has, that it is one of the most well studied phenomena in the whole of biology. So, just to give you one figure, between 2013 and 2023 alone, there were about 3 lakh papers that were published on this topic, and this is not to say that aging work started in 2013. No, aging work started long ago. In fact, as I am going to show you, even Aristotle was writing about aging. Okay, so aging has been studied forever, and this figure that I am giving you is by no means an exceptional period of activity during that those 10 years. This is like the rate at which aging papers get published. Now, obviously one then has to ask the question that why does one have such a massive interest in this particular topic, and turns out that there are multiple reasons for it, again somewhat interconnected to some extent. The first and perhaps the biggest reason is cultural. No one wishes to die, no one wishes to look old, no one wishes to feel old, okay. And this is something that we know is a cultural thing. I mean, take for example our own Mahabharata, right? You have the story of Yayati and Puru. So, Yayati was a king who for some reason was cursed by a sage that you will become old, and he did not want to become old, he wanted to enjoy life. So, he actually goes and tells his sons that, hey, will any of you exchange your youth for my old age so that I can enjoy youth for some more time. 4 of his 5 sons say sorry, not happening. The 5th son Puru says yes, okay, done, and they exchange their youth and senescence, and Yayati enjoys young age for some more time, and then at some point he realizes that it is not really taking him anywhere. So, at that point they basically exchange it back, and then Puru goes on to rule for many years, Yayati goes to heaven, and so on and so forth. The point I am trying to make is that this thing about enjoying youth, okay, and not getting old, this is mentioned in our epics, and by no means we are special. Okay. If you look at Bible for example, again there is this mention of this king called Methuselah, who apparently lives for some 900 plus years, and people have tried all kinds of ways to justify how that could have been possible. So, this thing about not wanting to die, not wanting to be old is one of the fundamental features of human psyche, and of course, in modern times we still have not figured out how to exchange youth, etc. So, in modern times what we do is we think in terms of cosmetics, or for people who have a little bit more money, we think in terms of cosmetic procedures. Now, there was a time when people thought that cosmetic procedures were only for the rich and the famous. However, one thing that we have understood now, even in India and in many Western countries, is people are, even common people who are not into show business or other things, even they are investing heavily into cosmetic procedures, and because of that each one of these things that I am showing you, the cosmetic business itself and the cosmetic procedure business, each one of them are like hundreds of $billion businesses in their own rights. So, obviously both these businesses depend in some sense on aging, that is their raw material, and their whole procedure or their whole reason for existence is trying to figure out how not to look old or how not to feel old and so on. However, this is just cosmetic. There is something even more important that has happened over the last, let us say 100 years or so, which has made aging a very important topic, and that stuff is in the context of our life expectancy. Now, what is life expectancy? Life expectancy is that when you are born, on an average, how long are you expected to live, right? Now, you can have life expectancy calculated at various ages. So, what I told you is life expectancy at birth, and one of the things that has happened over the last 100 years is that in almost every society, in every continent, the life expectancy of humans at birth have been going up. So, for example, if you look at Asia, this is where we have Asia, somewhere in 1950, 1955, this was about 42 years of age. A baby born in Asia could expect to live for about 42 years, whereas by 2025 or so, this is roughly speaking where we are. By this time this has gone up to about 70 plus, 72 or so, right. It is a little less than double. Now, why has this happened? This has happened because of multiple things. First of all, there has been greater food security, greater food production all over the world, and there has been access to clean water, access to hygienic living conditions. Medical science has made tremendous progress, because of which the impacts of infectious diseases have come down. This is because of two things, both the availability of lots of antibiotics and also the process of immunization, vaccination, and more importantly the medical care that we are able to give to babies, to mothers, to old age people, that medical care, the standard of the medical care has gone up quite a bit. Now, this is good. This is the kind of figure that we show everybody to show that humanity has been progressing over the last 100 years or so. However, this has led to a social issue, and the social issue is that because the life expectancy has gone up, the number of elderly in the society has also gone up, right. Now, because the number of elderly has gone up, it is not that they are living long and not suffering all those problems, they are, and because they are suffering all those problems, now the society needs to take care of them. And this, just to give you some figures, in 2025 in India alone had 102 million people above the age of 65, which represents about 7% of our population, right. Now, at the same time, our fertility rate, how many babies are being produced on an average per female, has gone down to 1.9, which is less than what is known as the replacement rate, which basically means that our population in 2025 has already started going down. Now, the effect of this will not be felt for some time, and our overall population number will increase for some time, but by 2070 or so our population is expected to go down quite a bit. And what is the impact of that? The impact of that is that, see, the old people, they become dependent on the young people, right, and the ratio of the dependent people to independent people, that ratio is going up, right. And because of this, people, the younger generation, they need to take care not only of their babies, they are now needed to take care of their elderly parents for a much longer time. And of course, the other major thing that is happening is that the cost of health care, particularly for the elderly people, that cost is also going up. Now, this again is not an India specific problem. This particular issue is already real for many countries, the biggest example for which is China, right. So, remember, China had a one child policy for quite some time, because of which most parents have just one kid. Now, let us say you have a male kid, and then that male goes grows up, becomes adult, that male marries a female, both of them are single child. So, now this particular couple, they have to take care of two sets of parents, right. So, 2 plus 2, 4 people become dependent on this one couple, and this particular issue has become extremely important for China, and they are doing all kinds of things to solve it. China, of course, is also facing this same problem of a shrinking population, which also explains why China is investing so heavily in AI and robotics. Anyway, that is a different ball game altogether. The main point over here is that because of these issues, that number of elderly in the society are increasing all over the world, because of which there is an enormous emphasis to figure out how to keep people healthy for as long as possible. Now, typically till this date we have been focusing on what is known as a lifespan. How long does the person live? However, of late the focus has somewhat changed into what is known as health span. How long is the person able to live healthily in a way in which they are not dependent on other people, and in a way that they are able to enjoy life. And this span, when they are able to live healthily, this is what is known as a health span, and a lot of emphasis or research emphasis these days is on how to enhance the health span of individuals. Now, whatever I talked to you about till this point, these are the social reasons, the cultural reasons. But from a pure scientific perspective as well, there is, aging is a huge enigma. Why is that? That is because we know, we have seen that all else being equal, natural selection is supposed to increase the fitness of organisms. And the fitness of organism, of course, they are defined in terms of how many babies they can produce, how long they can live, and these are exactly the two things, reproduction and survivorship, that is being reduced by aging. That is why aging is definitely reducing the fitness of organisms. If that be the case, why has selection not been able to get rid of aging? Okay. And remember, we are not talking about aging being a recent phenomena. Aging has been there forever, as I told you, right? Even in the time of Mahabharata and Aristotle, people were writing about aging. So, if that be the case, aging has been there forever, for millions of years. So, why has natural selection, such a powerful evolutionary force, not been able to get rid of aging after these many years? Okay, what prevents it? And this question remains one of the major unanswered questions in biology. Now, as we are going to show you, it is not totally unanswered. We have some very good answers here and there, but we still have not been able to come up with an overarching theory of aging which kind of takes care of everything. Why selection has not been able to get rid of aging? Evolutionary biology has some answer, as I said, but it has not been able to integrate that answer with other kinds of molecular insights, as we are going to talk about. So, as I was telling you, one of the earliest treatises, scientific treatise on aging, was Aristotle's On Longevity and Shortness of Life, written in 350 BC. Okay. And people have been theorizing about why aging happens for a very, very long time, and in 1990, that is 35 years back, one paper listed and reviewed 300 plus theories of aging. Okay. I was telling you, right, that it is a very, very well studied topic in biology. That is just one evidence for that. Now, many of these theories now we know conclusively are wrong, they are just not correct. Okay. And we obviously cannot look at even the subset which has some possibility. So, we are going to look at maybe a few, some of the more prominent ones, and we are going to also discuss what are the evidences that we have to support or not support each one of those theories. However, that stuff is what we are going to do in the next discussion and the one after that. See you.